Hello and welcome to my Tech Fun, and this is another resin comparison video where I will compare Prusa Standard Tough Resin versus Elegoo Water Washable Resin. I know you will probably say that this is not fair comparison because Elegoo also has their ABS-like resin, but this is what I have, and these test specimens are sent to me by my viewers, some kind of donation. Prusa Tough Resin is sent to me by Samuel from Slovakia. It is printed on Prusa SL1, so thank you Samuel for these test specimens. And these test specimens are printed on Elegoo Mars, and they are given to me by Csongor from Hungary. Csongor, he did that review of the Csongor resin vats in one of my previous videos. I try to make some kind of standard with my test specimens in my experiments, so the results are comparable with each other, even with those printed with FDM printers. Only what I don't have here is the layer adhesion test, because we don't have here that layer adhesion. I even have experiments, but only with the Elegoo Water Washable Resin, the orientation, and there is not significant difference in printing orientation with the SLA 3D printing. Let's take a closer look of these test specimens. I already started with the experiment, so that's why these are broken, but I have two from each. So as you can see, this Prusa Tough Resin has a nice transparent green color. And Elegoo Water Washable Resin is in gray color. It is very commonly used to print some figures. I even have this 50% benchy. Look how quality is its surface and details. That's really circular, that small window. The overhangs are also perfect. So this is how it looks like. A benchy printed on SLA 3D printer. Just for comparison, this one is a full-size benchy. Printed on Prusa Mark III's. I think it's from Polytera PLA. I think here we can see significant difference because this is the lines from the layer height, and here almost we cannot see those lines. And now let's start with the testing, and the first one is the tensile test. These are my test specimens for tensile strength test. And the smallest cross-section area is 4 by 4 millimeters, and I will just pull it until it doesn't break. And this is my test setup, 1-ton chain hoist, and here I have 500 kilogram crank scale, and there will be my test specimens attached. This is how they broke. So this test specimens even broke on different locations, but I don't know, is it visible on camera that how different is the cross-section area of the breaking. Next experiment is the shear stress, and it is a two-sided shear stress. Cross-section area of this pin is 5 millimeters, but it has to be doubled, the area of the shear stress. And here they are. As usual, I couldn't find all the pieces, but for the feeling, in both cases they broke very suddenly compared to the, I don't know, FDM filaments, for example. But let's see the numbers now. And this is the bending test. It is based on ISO 178, so 3-point bending test. And here I will record the load on 2 mm deformation and also the maximal load. The distance between supports is 50 millimeters. This experiment is based on Sharpie impact test. I will place here a test specimen and I have here half kilogram hammer and it will swing to the other side, and it depends on the position I can calculate how much energy is used for breaking the test specimen. ELEGOO Water Washable Resin. The 0. Prusa Resin. Zero position. This is the scale and this is the position of the hammer after first zeroing, and this is after the second one, so you can see it is very repeatable, this experiment. So let's mark the 0 line. And this is the position after breaking the Prusa resin test specimen. And this one is breaking the Elegoo, and it looks like they have the same position. So let's mark this line too, and if I measure the distance between these two lines, it is 16 millimeters, and from this I can calculate the energy used for breaking the test specimen. In this twist test I have these test specimens. In diameter they are 6 millimeters, and the length of the cylindrical part is 30 millimeters, and this side goes into the vase and the other side goes into 10 millimeter wrench. And here I have a torque meter, and I will rotate it until it doesn't break, and I will follow with this upper camera how much twist I can make before it breaks. Elegoo Water Washable Resin. .3. 1.4. 1.6. 1.7. I hope it was visible on camera that these are very brittle materials. Prusa resin was a little bit stronger, but in both cases they broke very suddenly. A lot of broken resin parts here. It is hard to talk about the conclusions because these test specimens are printed by two different persons on two different CD printers. But anyway, this is what I got, and I'm very thankful for. Thank you Csongor and Samuel for sending me these test specimens. And also in the near future I will have finally the test specimens for ESAN 2 type of the resin, tough and standard. And also in another video I will test the Siraya blue tenacious and the mix of these two in 50-50%, and that will be printed by same person on same 3D printer, so those results will be more comparable in each other in one video. I know a lot of you are asking for creep test, and I am preparing a creep and wearing test. My creep test will be based on a tensile and a 3-point bending test. I saw that Stefan on CNC Kitchen also preparing a creep test, and his test will be based on the torque, and it would be good to test the same materials, but I don't know, maybe I'm too small to cooperate with. But anyway, I'm most curious about some ABS parts, because those are very commonly used in Voron Core X5 CD printer. But that's the subject of the future. First I have to finish these videos in progress. And well, I hope I could give you some useful information, and you will follow me to my next video too. Thank you for watching, and happy printing!